Brazing and soldering both use a filler metals to permanently join the metal parts, but there is no melting of the base metals. The brazing or multi-soldering usually used over diffusion welding if the metal have full weldability or dissimilar metals are to be joined. Third, intense heat of the welding may damage the components, and if the geometry of the joint is not suitable for the welding. Finally, when high strength is not required. The main disadvantages on the limitation of the bracings are: first, the joint strength is generally going to be less than the welded joints. The joint strength is likely to be less than the strength of the base metals. A high surface temperatures may weaken the brazed joint. Finally, the color of the brazing metal may not match the color of the base metal parts. The brazing have very wide applications, like in the automotive industry, the electrical equipment, the cutting tools, the jewelry, the chemical process industry, plumbing, and the heating contractors using the joint metal pipes by the brazing. And finally, the repair and the maintenance works. The butt and the lap joints are common in the brazed joints. The geometry of the butt joints is usually adopted for the brazing. The lap joints are more widely used since they provide a larger interface area between the parts. The film metals is brazed and the lap joints is bonded to the base part throughout the entire interface area rather than only at the edges. The desirable brazing film metal characteristics are: first, the melting temperature of the film metal is compatible with the base metal. Second, the low surface tension in the liquid phase for the good workability. Third, high fluidity for the penetration into the interface. Fourth, capable of being braced into a joint of an adequate strength for application. Fifth, avoid the chemical and physical interaction with the base metal. The film metals for the brazing is selected based on the application. The most common types of the film metals are the aluminum and the silicon, the copper, the copper and the phosphorus, copper and the zinc, and the gold and silver. The two most common types of the film metal applying methods are the torch and the filler rod, and the ring of the film metal at the entrance of the gap. The brazing fluxes have the similar purposes as in the welding. They dissolve, combine with, and otherwise inhibit the formation of the oxides and other unwanted bioproducts in the brazing process. The characteristics of the good flux include the low melting temperature, low viscosity so it can be displaced by the filament metal, facilitate the wetting, and the protect the joint until the solidification of the filament metal. The heating methods used in the brazing are the torch brazing, the furnace brazing, the induction brazing, the resistance brazing, the table brazing, and the infrared brazing. The soldering is the joining process in which a filament metal with a melting temperature less than or equal to 450 degrees is melted and distributed by the capillary action between the faying surfaces of the metal parts being joined. No melting of the base metal, but the filament metal wets and combines with the base metal to form the metallurgical bond. The filament metal, called the solder, is closely associated with the electrical assembly processes. The main advantages are the lower energy than the brazing or the fusion welding. Also, has a variety of the heating methods available. The joints have good electrical and thermal conductivity. Finally, is easy repair and rework. The disadvantages are the low joint strength unless reinforced mechanically. Also, the joint weakens or melts at elevated temperatures. The solders traditionally alloys of tin and lead. The lead is poisonous and is percentage minimized in most solders. The tin is chemically active at soldering temperatures and promotes wetting action for successful joining. In soldering copper, the copper and tin form intermetallic compounds that strengthen the bond. The silver and the antimony also used for soldering alloys. The functions of the soldering fluxes: be molten at soldering temperatures, remove the oxide films and tarnish from the base part surfaces, prevent the oxidation during the heating, promote the wetting of the faying surfaces, be readily displaced by the molten solders during the process, and leave a residue that is non-corrosive and non-conductive.